Hi guys, in this video let us go with the various operations of binary trees using linked representation. The figure represents that there are five ways or five operations or five types of operations that we can apply on the binary trees. First one is insertion, second one is traversal, third one is search, fourth one is copying, and last is deletion. So in this video we will study about the insertion. So look over the diagram, figure 10.9. I wanted to insert an item temp with the information field containing the data as I at the required position. So first I need to get the position, right? So whether it is in the left part of the subtree or else in the right part of the subtree. So for that let me take an array D that represents the direction where the node temp has to be inserted, right? So the D contains the direction where I need to place the node, right? It starts from the root node, then it moves towards the left indicated by L, and then it moves towards the right indicated by R, and then again left if is L, or else if it is right then go to the right. Finally, if the pointer points to null, at that position the node temp can be inserted, or otherwise the node temp cannot be inserted. To achieve this, guys, one has to start from the root node. So let us take two pointers, previous and current. So as we used to take it in the previous topics, so previous will always point to the parent node and current will always point to the child node. So at the initial stage, previous will be marked as null and current will be marked at the root. So it is as how we are representing in this piece of code. So previous is marked as null and current is marked as root. The next is that keep on updating the node pointed by the current towards the left if it is the direction making as L, or otherwise update it towards the right. The pointer variable previous always points to the parent node and the current points to the child node. Once all the directions are over within the array, if current is pointing to the null, then insert the node temp towards the left or right based on the last direction wherever it was marking at, or otherwise display an error message that we cannot insert the node at the required position, right? So we can write a function here, C function, that helps us to insert the data, to insert the node in the binary tree based on the particular direction. So the function starts here, the declaration, it's of the type node, so it is accepting two parameters, so item and the root is again the type of node. So I am going to take three pointers or three variables, temp, current and previous of the type node, that will help me to insert the data at the particular position. Then I am going to take the direction array that helps me to insert the direction where I need to insert my node. The I here will be acting as if like a index point. Okay. So at the earlier stage we need to call out the temp, or else we need to create a temp node that we are trying to insert at the particular position. So through the get node function I will get the temp. So at the information of the temp, so information field of the temp, I am going to place an item. Initially the left link as well as the right link of the temp will be marked as null. So first we will check all the conditions whether it satisfies, and then later on we start inserting the node at the particular position. Either it may be a left subtree or a right subtree. So first we will go or check with the whether the tree exists or not. So we'll check at the line if root is equal to null. So if it is so, then return temp, whatever the temp node that I am creating, that will be marked as the root node, or otherwise the program will be asking for the direction that where you want to insert. If the root is not null, then it will ask for the direction where you want to insert. So I will give the direction okay, by accepting from the keyboard using the scanf statement. Next I am converting the direction to over all the upper characters, like D will be printed as capital D, I will be taken as capital I, R will be taken as capital R, and so on. So at the initial stage, previous will be marked null, as we discussed in the previous before the starting of this explanation of this function or a code. Then current will be marked as root. So we start with the initial stage. For I is equal to 0, so we are comparing up till the length of the strength is completed. So we will be incrementing stage by stage. So if at the initial stage current is at null, so it will be coming out of the loop. If current is pointing to the null, the current is pointing to the root. So if root is null, then no use, right? So if it is not so, the previous will be marking to the current. The previous will be marking to the current, and current will be incremented. So if direction, whatever that I am checking with the index I, is actually marking as L, so I will go at the left link to update the point. So current is equal to current left link. Or else if the direction where in the left link it is not present, then I will go to the right link. So else you can find the statement that current is equal to current right link. So suppose if current is not equal to null, or I is not equal to the string length of direction, it means what? I cannot insert the node at the possible stage. So whatever node I will be creating at the initial stage using the get node function, so I am going to free it off. So it means what? I am going to delete the temp node, so and I am going to return the root, whatever it was present before. If this is not going to get executed, then at the place I minus 1, if it is at the left subtree, then previous will be updating with the left link and temp will be inserted there. And then otherwise, if it is not left, so if it is a right, then previous will be marking to the right link or a right subtree, and then temp will be inserted there. Lastly, after inserting all the nodes required, or else node required, then we will return the root. The root, why we will return? Because every time I start my tree with the root, right? So this was the code regarding the insertion operation in the binary trees. So in the next video we will talk about the traversals.